Welcome to the class, children. Hope all are safe and healthy. Today's class, we are going to learn in geography, lithosphere, endogenetic process, part 2. Part 1, I explained the spheres of the earth, structure of the earth, rocks and its types, and a rock cycle. Today about geomorphic process. What is geomorphic process? What we are going to learn in this? About geomorphic process, going to learn the internal process and the endogenetic process, external process or exogenetic process, about its types. Going to learn, okay? Endogenetic and exogenetic process. The forces that act from the Earth's interior towards the Earth's surface are called internal processes or endogenetic processes. In the screen it is given endogenic and exogenic forces. The both are the same only. These forces build the landscape and create topographic relief. The forces that act on the surface of the earth due to natural agents like running water, glaciers, wind, waves, etc. are called external process or exogenetic process. These external processes steer the landscape down into relatively low elevated plains and shapes the landform created by endogenetic process. Next, internal process. The internal process generates heat and eject materials from deep below the earth crust. Internal radioactivity is the principal source of power for this process. So that is Earth's internal process. Here you can see in the screen tectonic plates or plate tectonics. The lithosphere is divided into a number of huge slabs of rocks that only called tectonic plates. These tectonic plates are divided into major and minor plates. These plates float independently over the mantle. Collisions of these plates produce mountain ranges and other irregular surface features both on land and the ocean floor. This phenomenon is called plate tectonics. You can see in the screen down plate tectonics. The movement of tectonic plates is due to thermal energy from the mantle. Now we have a better understanding about the plate movements and its relations to earthquake and volcanic activities. Okay, children? Now the types of plate. Types of plate boundaries. 3 types are there: divergent plate boundary, transform plate boundary and convergent plate boundary. What is convergent boundary? Here the plate moves toward each other and sometimes a plate sinks under another. If you see the screen, that the convergent plate, in the third one here is given convergent plate. The plate moves toward each other and sometimes a plate sinks under another. This location, the location where the sinking of a plate occurs, is called a subduction zone. Example, fold mountain. Where is fold mountain? That great example, Himalayas. Okay. The another one, divergent boundary. The first one, divergent plate boundary. See the screen. Here the plates pull away from each other as magma pushes up from the mantle. Example, mid-Atlantic ridge. In the textbook also it's very clearly given. As the same in the screen also clearly you can see. Another one, conservative or transform. In the second one, transform boundary. Here the plates slide horizontally past each other. So plates slide horizontally past each other. So that transform plate boundary. Clear, children? So three types: divergent, convergent, transform. Okay. Another, movements of continental plates. Here you can see convergent plate boundary, how the trenches, oceanic plate, continental plate, melting, earthquake, volcanoes. As the same in divergent plate boundary, it is separately the tectonic plates move away from each other at the divergent plate boundary. And here transform boundary, they move past each other. Okay, very clearly I explained this one. The next one, the continental plates, that is the movements of continental plates. Due to lateral compressional forces, the plates are forced to move upwards and downwards. This is called folding. So, what is folding? The lateral compressional forces, the plates are forced to move upwards and downwards. This is called folding. Okay. Mountains formed by folding. Mountains formed by folding are called fold mountains. The process of folding creates lofty mountain ranges such as the Himalayas and the Alps. According to plate tectonics, the plates are in constant motion with an average rate of few centimeters per year. The movement might seem slow, but over millions of years, the plates and the continents riding on them move a long way. For example, about 250 million years ago, the Indian plate was a part of the Gondwana land, which comprised of modern Africa, Australia, Antarctica and South America. Okay, children, approximately 140 million years ago, the Indian plate broke away from the ancient supercontinent Gondwana and began moving north and collided with Asia. So the collision with the Eurasian plate, you can see here, Earth major orogenic belt, here very clearly given, children, the collision with the Eurasian plate along the boundary between India and Nepal. India and Nepal formed the orogenic belt that created the Tibetan plateau and the mighty Himalayan mountains. Here in the Eurasian, the circumpacific and alpine Himalayan orogenic belts, Earth present day major mountain building belts in the map very clearly given, children. Okay, the next one, earthquakes. Earthquakes are generally caused by the sudden vibration in the earth crust, which spreads outward in all directions as waves from the source of disturbance. The point of origin of an earthquake is called focus, that is hypocenter, which generates a series of elastic waves. Epicenter is a point on the earth's surface that lies directly above the focus. The impact of the earthquake is felt the most at the epicenter. Here, the type of seismic waves. Three types of seismic waves are there: primary waves, secondary waves, surface waves. There are three types of seismic waves. Primary waves called P waves, secondary waves called S waves, surface or long waves it is called L waves. Okay children, the picture is very clearly given. Earthquakes generate seismic waves. The nature, force and speed of these seismic waves depend on the nature of the medium through which it passes. Accordingly, there are three major types of waves. Primary or P waves are the fastest. Primary or P waves are the fastest of all the earthquakes waves and the first to reach the epicenter. These waves pass through solid, liquid and gases, either through push or pull with an average velocity of 5.3 km per second to 10.6 km per second. Okay children. And secondary or S waves, it travel only through solid. These transverse waves shake the ground perpendicular to the direction in which they propagate. The average velocity of these waves is 1 km per second to 8 km per second. The third one is L waves or surface wave. These are similar to P waves, but they travel primarily along the ground surface. These waves travel comparatively slower and are the most destructive waves. The average velocity of these waves are 1 km per second to 5 km per second. Do you know children, C.F. Richter, he devised a scale to measure the magnitude of earthquakes. The scale relates to the energy released at the epicenter and provide an estimation of the severity of an earthquake. It is an open-ended scale. The highest magnitude ever recorded is 9.5 on Richter scale. And the instrument which records the earthquake waves is called a seismograph. Now you can see in the screen seismograph or seismometer. The science that deals with earthquakes is called seismology. Clear children? So till the second part 2 it's come to an end. From this you people know about geomorphic process, internal process, movements of continental plates and earthquakes and the seismic waves. Okay children, I hope you people understood this chapter. Okay children, thank you so much.